Hello, everyone. My name is Egli. I completed my third year of medical school through St. George's University, and I am currently working with Dr. Sivamani at Integrative Skin Science and Research as a clinical research fellow. I will be doing my poster presentation on the impact of sequencing depth on the whole genome sequencing-based characterization of the skin microbiome. So just a little background. Human skin is colonized by a diverse microbial community, and shifts in the diversity have been associated with multiple skin conditions. One of the challenges is to balance the accuracy of the skin microbiome versus the economic cost of sequencing the microbiome. To assess this, a set of 48 skin swabs were sequenced with whole genome sequencing and analyzed based on 3 different read depths. Sequencing depths were set as deep 30M, which was done 28.7 million reads per sample, shallow 6M, done at 6.2 million reads per sample, and shallow 3M, done at 3 million reads per sample. Analysis of variance was utilized to determine differences between the relative abundance outputs of the different read depths. Shotgun metagenomic sequencing provides a more comprehensive taxonomic analysis compared to the traditional 16S rRNA technique. However, shotgun sequencing can be cost prohibitive, especially with deeper reads. To cost optimize shotgun, the reliability at different depths must be assessed. So these were the results. When considering the Shannon diversity, there was no statistical difference between the 3 read depths. When comparing the outputs of the top 10 species found on the skin, there was no statistical differences. When considering the strains of bacteria, there were no significant differences for the top 20 strains, with a p-value of 0.86. For all species of fungi, there were no significant differences for the top 10 species with a p-value of 0.99, nor for the top 20 strains of fungi with a p-value of 0.99. The results in this graph show the comparison of the 3 sequencing depths of deep, shallow 6M, and shallow 3M. As is depicted, there were no statistically significant results in the top 10 species or top 20 strains of bacteria between the read depths. The chart on the left lists the top 20 strains of bacteria in the order of abundance as found in the microbiome of the studied swabs. As you can see, there was no statistical differences in the different sequencing depths of any of the strains considered. The chart on the right lists the top 10 species found in the study microbiome. There were no statistically significant differences found at the species level. The study also included the top species and strains of fungi and found the same results. There were no differences in the results between the 3 levels of sequencing. So in conclusion, these findings suggest that sequencing depth does not influence the top 10 species or top 20 strains of bacteria or fungi. Deeper sequencing reads may detect esoteric bacteria within the microbiome, but may not be necessary for analysis of the most abundant skin microorganisms. The further suggests that sequencing of the skin microbiome to the deeper level in the study may not be worth the economic costs. So if you have any further questions, this is my contact information below, so you feel free to reach out. And with that, I want to thank you for your time and enjoy the rest of your day.